Okay. When we graph these sorts of problems, when we look and we see 5, 6, 7, 8, 9, and we know that it's x is going to be greater than 7, and a fifth, or as some people preferred, 7.2. When we go right here, we make our open circle and we shade. What we're doing is we're showing the answer to this. We're showing the answer to this in two different ways, really. In one way, one of the ways that we're showing the answer is graphically, right? This is way 1, and this is the graph. Okay? Then what we have is this right here. We have this x is greater than 7.5. And this is another way of showing the answer. Not way 1, way 2. Way 2, and we call this inequality notation. Inequality notation. And this green way of showing things we're comfortable with. This orange way of showing things we've seen before. But I want to introduce you guys to another way of doing it. This is the way that we tend to do things in math class. This is the way we do things in algebra classes. But when we're referring to these sets of numbers in science, we have a different way of referring to them. In science classes, what we tend to call it is, we call it two different things. We call it interval, or set notation. And these are essentially the same thing. Interval notation is the same as set notation. Different sciences refer to it in different ways. So make sure you guys write this down in your notes. This is going to be the important part, because this is the part that's not review. And this is our main lesson for today. This is our 2.7 lesson. Okay? Interval or set notation. Interval notation and set notation, they mean the same thing. They substitute in for each other. They're the same thing. They're just, sometimes we call it one, sometimes we call it the other, based on whatever the scientific discipline is. And pretty much what this means is when we look at something like our inequality notation, x is greater than 7. This would be 7.5. 7.2. What I'm going to be doing is I'm going to try to express this in as little information as possible, or as small of a notation as possible. So what I really want to know when I'm thinking about this set, because this is a large group of numbers, right? If I were to have a set of everybody in this room, I'd have to list everybody's name. There's Victor, there's David, there's Tyler, there's Alex, there's Jace, there's Devin. And I could go on and on. I could say all of your names, and that is the set of people in this room. Sometimes we want to know a set of numbers, right? If I were to ask for a set of numbers, like how old is everybody in this room, for example, how many of you guys are 14? Okay, there's a lot of 14. So 14 age in the room. So we have 14, 15. 15's represented. Anybody 16? 17? Did I see a 16? 18, 19, 20, 21, 22, 23, 24. And we have to go all the way to 34 to get to me. Okay? And so how I would represent all the ages in this room is like this. This is the set of everybody's age. We have 14, 15, 16, and 34-year-olds in this room. Now, clearly there are more of some of these than others. Not a whole lot of 34-year-olds in this room right now. But this is how we would represent that set of numbers. Okay? To represent this set of numbers, that x is greater than 7.2, well, what I'm going to do, instead of listing every single number that is greater than 7.2, well, I can't list every single number that's greater than 7.2. It's infinite. There's 7.3, there's 7.4, there's 7.5. And I could keep doing this until we were all dead, and I would never actually get to all the numbers that were greater than 7.2. So instead of doing that, because I want to save some time, and mathematicians by nature are a lazy bunch, I'm trying to find a way of listing all those numbers without having to say them all. But I see I started at a low number, and then I started to go higher and higher and higher. And so when we think about set notation as an interval, I think of the lowest number first. The lowest number, and then I want to list the highest number. Okay? So for 7.2, what's the lowest number? Well, I don't have to look far. I just have to look at my graph here. And to figure out where the lowest number is, well, it's right here. It's at 7.2. So for interval notation, my lowest number is going to be 7.2. And then I'm going to make a comma. And then what's my highest number? Well, this purple line from my graph, this could go on and on and on and on and on forever. I could keep drawing it. I could walk into Miss McFallow's room and I'd still be drawing it. And I'd keep going and going and going. I'd go to the car wash. I'd go all the way up 82nd Avenue. I'd go to the airport. I'd cross into Washington. I'd end up in Canada. I'd still be drawing this line. And then I'd have to loop all the way back around. I'd come back through Greenland. I'd come all the way over. This line goes on forever. And we represent forever by saying infinity. But in this case, it's important to note that it's a positive infinity. We're going infinity in a positive direction. We're not going negative numbers forever. We're going positive. And so this is how I would represent this exact same interval. I represent it through this graph, through this inequality notation, and this is way 3. This is going to be interval notation. 7.2 all the way to positive infinity. Questions on this? I want to show you guys a couple wrinkles because this is the most basic way. You guys all have this in your notes? Okay. So, I'm going to come up with another inequality. Okay, so I have x is less than, we'll say 3. Okay, x is less than 3. So now, keeping in mind what interval notation is and what we just went over, remember I have the lowest number, comma, the highest number. Okay, so when I say x is less than 3, what is the lowest number x could be? I said negative infinity, right? If this were a number line, I'd have 1, 2, 3. I'd have an open circle, and it would go like this. This would be negative infinity. So I'd represent that as negative infinity. And then the highest number would be 3. Okay? Yeah?
Is there a way to make it different to less than or equal to, or just plain less than?
Oh, Essen, you're reading my mind right now. Essen was just asking, is there a way to signify that if it's different for less than or equal to or greater than or equal to? So let's imagine instead of x is less than 3, I had x is less than or equal to 3. And when I make my graph, it's going to look very similar, except this time, 1, 2, 3, it's a closed circle, right? And so then I go on for infinity. And so what's the lowest number? Well, it's still negative infinity. What's the highest number? Well, it's still 3. But how do I show that it's different? And the way that we show that it's different, that 3 is included in this interval, is we give it a bracket like that. Negative infinity is still a parentheses. Negative infinity is not a hard number. Like 1, 2, 3, 4, those are hard numbers. Infinity is more of a concept. So we don't put a bracket around infinity because it's theoretical. We still leave it as a parentheses, but for the 3, we would give it a bracket. Same too, if perhaps I had something like this. If I had x is greater than or equal to 2, my 2 in this case would now be my lowest number. Positive infinity is my highest number. I'd put the bracket around the 2 and the parentheses around the infinity. You guys getting this down in your notes? I want to make sure. It's a little tricky, but it's not new information. It's just a different way of expressing it. It's just a different way of expressing information that we already had. So imagine instead I had a number line of our ages. Here's 14, here's 15, 16, and then all the way over here is 34 to represent me. And I wanted to represent in this number line all the possible ages of people in this room. There's no one under 14. There's no one over 34. So if I were to represent this as a number line, I'd represent it like this. Someone's 14, someone's 34, and somewhere in the middle is everybody in this room. So in this regard, in this interval of possible ages of people in this room, the lowest number is 14. The highest number, 34, and they're inclusive, right? They're dots to show that they count, so I put it in brackets. Now let's imagine my 35th birthday was tomorrow. I'm not quite 35, and it's not actually tomorrow, but let's imagine it is. I will still take presents if you want to give me any. Let's imagine my 35th birthday is tomorrow. So I'm not quite 35, but I'm very close to 35. Here, if I were to include this, my lowest number would be 14. My highest number would be 35, but since I'm not quite 35, I'd leave it as a parentheses to show that it's not included. Thumbs up, clear skies, thumbs sideways, partly cloudy, thumbs down. Victor, you just spoke Latin to me and I don't get it. Cool. I think it can be a challenging concept, and there's a couple questions on the homework that are going to ask you to do this, specifically on page 28. It's going to ask you to rewrite all of these inequalities in this notation. Refer to your notes, talk to each other. The information is the same, it's just a different way of presenting it. It's kind of like the way that sometimes we write, sometimes we speak. It's very similar to that. But that said, I'll go ahead and power this off and we can answer some homework questions from last night.